Welcome, everyone. Thank you for joining us today for the IBM Cognos TM1 Proven Practices and Templates for Version Scenario Management and Month-End Closing Procedures. A couple of things before we get started. We are recording today's session, so if you have any objections, you may disconnect at this time. Also, I will be monitoring the chat box, so if you have a question anytime during the presentation, please feel free to post it, and I will be collecting all questions and presenting them to Andreas. Also, you may download today's presentation by clicking on the little folder icon in the top left corner of your screen. And Andreas, if you could begin, please.
Good day, good morning, good evening, everybody. So thank you for attending the session and for taking the time today. Today we will be diving into version scenario management, proven practices around version scenario management and month-end closing procedures. And this is a deeper dive into a topic that we introduced in our first session on August 5th, where we looked at these proven practices in a more general way, and today is more, it's a deep dive. So we'll start with introducing or reintroducing version management proven practices. We'll then look at an example of a not so optimal version management methodology. And then we'll look at proven practices around version management and introduce a design template, a design example that you also may download. So Sophia can tell you where the download link is for that example. Give you an overview of that design example. We'll look at its version dimension structure, version dimension attributes, and version management processing. And we will also take a quick look at an iteration or variant of that version dimension for reporting and analysis. So what that means is primarily we're looking at this for forecasting and planning purposes, but for a reporting and analysis cube, one could use the same version dimension, but it would be a little bit of an overkill, a little bit too sophisticated because our version management carries multiple iterations and so forth. For reporting and analysis, we would use a simplified version of that, and that's what we'll look at in that last part. And with that, let's review. Introduction to version management. Version management or scenario management is a key component of most forecasting, budgeting, and planning models. And the design of that dimension of the version scenario dimension is the pivotal starting point from our perspective for a good overall FP&A model design. And that is because your cube rules, the calculation rules, are often related to specific versions, either or, forecast, plan, budget, maybe all of them, and variances. And therefore, your well-designed version dimension will provide good cube rules to be developed, while a poorly designed one might lock you into having to develop cube rules that are just not optimal. At the same time, version scenario management tasks, submission, seeding, and all that is crucially reliant on the version dimension elements, structures, and the related metadata, right? So here are the general design guidelines for a version management methodology. And before we get into that, if you have a very small model and that small model doesn't adhere to those guidelines, but it's still working, there's nothing wrong or bad about that. This is all good. So this is really here, these design guidelines are meant for larger models where have a large number of leaf level elements where performance is really key. So for such models, your leaf level rules should not apply to any submitted historical versions. In other words, if you archive a version, in planners have inputted a version and people you lock it now, make it read only. Managers are reviewing it and then they say, yes, we're good, we're done. And you submit that version, archive it off, create a frozen version. No leaf level rules should apply to those. That means the left side of the planning cube rules shall only include, I call it here, open versions. Those are the versions that may or may not be open for planning at any given time. So the left side of the leaf level cube rules should not include versions that are historical, that are submitted versions. There should be a fixed number of open versions. That means the open versions can be included on the left side of the rules, in the rule area. And those open versions are then submitted to or copied to the historical closed versions. So closed versions are not rules, only C-level rules if applicable. Data in those historical versions should be quote-unquote frozen. Those closed versions should not be subject to rule evaluations at the leaf level. Only open versions should be. And, in a good design, you should be able to copy data from a historical version to an open version or a working iteration, if you will, to allow for forecast or plan seeding. And, again, this is all particularly important for a system with larger data volumes. Let's take a look at the rule area. Why do we not want to have leaf-level rules to apply to submitted historical versions? Why should the left side of the rules only include open versions, and why should there be a fixed number? Well, here's why. Now, TM1 will evaluate a cell for rules if the cell is identified by a rule or feeder area. Or, we evaluate a cell for rules if the cell is identified by a rule area, not by a feeder area. That evaluation comes at a cost. So if you look at this rule there in red, if I have a rule like that, and again, we've all written rules like that, and we do write rules like that, it depends on the context. If you have a large planning cube, you should avoid cubes like that. If it's smaller cubes or cubes that serve another purpose, there's nothing wrong with this cube, with such a rule per se, right? But if you have a rule like this is the extreme case here, the left side of the rule applies to every leaf. That means that TM1 will evaluate each intersection. Okay? And that can add many seconds to even minutes to the query time of large input cubes. If, however, you write the rule only such that the left side includes the elements that really should be rule-derived, you will have no rule evaluation for versions other than the two versions in this case. In the green rule here says forecast and plan that are in that rule. So if you have open versions, your open versions should be on the left side of the rule. The closed ones shouldn't even be mentioned in there. That means that if people look at submitted data, frozen data, leaf-level rules will simply not be evaluated, and the performance against those versions will be very, very fast. So open versus closed versions. Well, what we like to do is we use dedicated versions for active or open forecasting and planning, and we use historical versions for our submissions. That means for security and workflow would be controlled against these versions here, actual forecast plan. This is your open forecast, your open plan. That's the one that you might lock periodically, temporarily for review and all that. Okay? So what you don't want here is have a calculation rule that checks on the status of a version and determines the applicability of a rule versus no rule. It means you always apply your rules to your open versions or to specific open versions. You just do not apply them to historical versions. So we took a quick example how we separate open or active versions and distinguish them from historical versions. Now, what's an example of a non-optimal version management methodology? In this example, where you have your version dimension, and let's say you have one version is called your 2015 plan iteration 1, plan iteration 2, 3, same thing for forecast, okay? If you have a version dimension like that, your pretty much only option will be to have relatively open rules and then to check on attributes if a version is open or what the version type is to determine what type of rule or if no rule is to be applied. And if you have a large input cube, your cube performance will degrade significantly due to those rules. So let's take a look at our design template. So this design template has the following main components. It has a version dimension. It has the version dimension has element attributes, some of which are mandatory that are needed. Some of those attributes are rule-based. We have some cube rule templates for variance analysis, and we have some turbo integrator processes for version management. So what does this version dimension look like? The version dimension leaf elements are grouped by open versions, working iterations, you could call them, and historical versions, which same as submitted versions. You may use an alias for your versions according to the current purpose, but do not use the alias in rules. You can use an alias in feeders. Don't use alias names in rules because that can lead to locking, often leads to locking because the alias needs to be reevaluated. You can change the version element names in this example, so you don't have to go with the same version element names that we're going into. You just may have to modify these examples a little bit, okay? What matters here is not how they're really called. What matters is the structural design of the version dimension, not the element names. In our example, we have some what-if scenarios versions. We're using those for best, worst case, what-if, case scenario planning, okay? And what's important is that all input models shall ideally one and the same version dimension. Do not use a version dimension and a separate version iteration dimension. You're adding another cube, you're adding more complexity, you're adding memory, and you're degrading performance. Now, what's important is that the working open versions in this input model, in this template, are not the approved ones. The version management process by itself will copy the latest approved plan and forecast to a historical version branch and assign and update the current forecast and current plan by attaching the last approved plan version as a child to current plan or forecast. last but not least, variances are all calculated through leveraging TM1's natural consolidation algorithm using feederless, just typo there, sea-level rules. So let me just quickly look at a question here. There's a question, are you recommending hard-coding versions on the LHS? I'm not sure what that means. Oh, left-hand side. Yes, we are recommending hard-coding the open versions on the left-hand side of the rules. Let me show you what this looks like. Should be able to see the architect window now on the bottom left-hand side of the screen. To bring in the version dimension. And again, you can download these examples. So your open versions, and what we tend to do is we put all of these open versions. It's a fixed number then to the left side of the rules. For example, here's just a simple actualization rule, okay? This is just representative of your planning rules. If, let's say, a forecast was reviewed and it's submitted, a TI process will copy the data from forecast into a historical version. Those are named according to a naming regime. We'll talk about that later. I'll show you how that functions. None of these will ever be part of a leaf level rule, and they will not be evaluated for leaf level rules. If we submit a forecast, the TI process will automatically update the following C levels: current forecast, current plan, and prior forecast. In this case, there is no prior forecast because I don't currently have a submitted forecast for 2015-08. I'll show you that later, how we will update that. Variances are calculated through C-level rules. You can see the C-level rules here. Relatively basic rules. We only have one that needs to be fed, which is the actual versus prior year actual percent variance. All of these here are feederless rules. They apply, yes, to historical versions too, but that's fine. They're C-level rules. There's really no penalty for applying those to every version. The key is not to evaluate leaf level. If you have a few million or many million leaves underneath these here, you don't want those to be evaluated for rules because it's really frozen data. So how do those work? You see here, my actuals versus forecast. Actuals is all based on current forecast and current plan. So I'm really measuring not the current working forecast because that's not finalized. I'm really measuring variance between forecast and plan, actuals and forecast, actuals and plan, based on the submitted last forecast and plan, okay? Obviously, because the TI automatically updates current with the properly current historical version, these variants are always calculated according to the latest state of my forecasting and planning model. So we looked at the structure here. look at these C-level rules, how those are done. Some of those rules just use regular dimension weights, right? And the percentage variances, for the percentage variance, you just create a percentage calculation. And you can see here that the percentage variance calculation is a feederless rule that's actually directly just quote-unquote fed or driven by the total variance, right? By the way, we have put these types of variance calculations into a cube with over 1 billion leaves, and it works really well. So this is just a schematic example of such a version dimension of the principal design. We've had some clients, customers, where we actually put a last year actual version in there. That is, yes, we are, by doing that, we are increasing the data in the cube. We did that because it was easier to do relative proportional spreading by having a separate version with last year's actuals. So that was really just a convenience thing. What we also did is we sometimes we create specific scenarios for what if plan versus what if forecast. Again, it doesn't really matter how you call your versions, how you name them. What's important is the structure. Now, how does the version management process work? It's really relatively straightforward, relatively easy. We have something here that we call the actuals through date, commonly used attribute of a version. That really means this version has actuals through, in this case here, 2014-10. And based on that, we have a rule that calculates what I call a version identifier. That rule-based name here is used when I submit a version in the context of version management. So if I submit forecast, the TI will take a look at what's the version ID, and it will then create a historical version with that version ID. And we have a dash here, and then the iteration. The version management process allows me to have as many iterations as I want. Again, the names do not matter. If you use this example and like it, but you don't like the name, take a look at the rule, change the rule. All you have to do is change the rule for version identifier, and whatever is in here, the TI process will pick up. Right? So it's flexible. Some customers don't like the naming convention we put in place here. We change the name in there. Right? It's not a problem. The TI will then, whenever you resubmit a forecast or plan, update current forecast, current plan, and prior forecast. So here it knows if I submit forecast 2014-10, if that's the current one, if I say, oh, this is not what I'm submitting, then it checks if there's a forecast 2014-09, then it will make that the prior forecast. Here's just a picture, the structure of the variance dimension. What you have here is a more sophisticated version that also includes some variance due to exchange rate. We're not going to get into that today. That might be topic of a session that we might be doing in 2017. So we talked about the version dimension template and its version attributes here, the version identifier. We talked about the actual through date. The other one that's important is the hierarchy suffix. That's the suffix that will be applied to a hierarchy snapshot during version management. So if during version management you want a backup of, let's say, your org hierarchy, or you want a version of that organizational hierarchy to be saved off in the context of version management, you can do that, and this will be the hierarchy suffix that that hierarchy snapshot will be given. So now we'll look at version management processing. So what we currently have here, and you see in this cube, our current forecast is currently 2015-09. That was the final iteration. So yeah, we're about a year back here in this model, going back in time. What I'm doing now, I'm going to look at the process, sys IBM version management. This is really the main process. These other processes here, are sub-processes. We don't call those directly. And what I'm going to do now is I will pretend I'm moving a month ahead. So I'll go to October. And what I will do then is I will resubmit forecast. So the way this process works here is it's very dynamic. I tell the process what the version dimension is, okay? I tell it what the source version is, and the parameters here are all documented. There's a PDF that you can access in the context of this webinar that gives you more detailed information on the various functionalities behind these parameters. Point is, if I leave this at submission yes, then the process will, and this is our first example, will a proper forecast submission. I do not enter a target version there because the target version is automatically determined based on that version identifier. And in the cube name, I can right now put up to 17 cubes. You can just increase that number if you like, right? So it will do that copy for all of those cubes. So before we do that, we need to change our version. We'll move a month ahead. So I will change this to 2015-10. My version identifier was updated, and I will run this. Now, my current forecast, if I refresh this, should now be 2015-10. I'll also now have a prior forecast, 2015-09. Obviously, the data is the same. I'm not changing the data right now in our example here, right? The final iteration. And you can see that we've done a few tests here with forecast 2015-10. Multiple iterations. And now at iteration 6. Actually, well, what we have now is this, the final now is our 7th forecast. So what would happen if I resubmit? All I have to do is run this again, resubmit. See what happens. and I'll have a version in iteration 7. So whenever I resubmit and the TI process finds that my target already exists, in other words, I already have a final iteration of 2015-10 for forecast, it will take a look at prior iterations, and if that is the case, it will make the old forecast my last iteration and the new one the last final. So there are actually 2 data copy operations involved in this case. Now I can do different things here too. I can only zero out the source version, in which case I can set this to yes, and it really only does a zero out. Or I can also say, let's set this to n. All I want to do, I want to make a backup. Forecast BK Kugelmeyer. Let's say I am a super user and I have access and security such that I'm allowed to do this, and I really want to make my own backup, not a sandbox, a proper backup that everybody can see. So what I do here is I run this, and let's take a look. Here's my personal backup in this case. Okay. So this is really something that we qualify as a snapshot, if you will, of a version, a snapshot in time. And again, you could run this for multiple cubes, right? Let's say you wanted to do such a snapshot, but what you really want to do is create a version you might want to use for seeding. So I could say source year, say let's take forecast again, but I want to, as the source year, I want to use 2014. And I want to take the 2014 data and actually put it into 2016. Time period dimension is time period. So again, you don't have to use the same structure. You just tell it which time period, what the time period dimension is. Okay. I'm just going to call this seeding test. So it took the 2014 data and populated it into 2016. So that's also, it's a very simplistic way of seeding. Yes, it can at times be helpful. You can use this same process here to do an overwrite for a rollover. So you could actually overwrite an actual open version with this. Okay. Again, don't forget you can also do a zero out. Not allowing you, it won't allow you to do a zero out of actuals. I think I have a check in there. You could have a specific data source dimension and specify a separate source data source versus a target data source. You can also turn off the update of current forecast and plan, for example. Speaking of the snapshots here, we created these snapshots of the cost center hierarchy. What does this look like? You see all the snapshots that were created. This is the forecast snapshot that we created. So it did that automatically. So along with the October forecast, the total company hierarchy was snapshotted and hence frozen. So we know that this was the org roll-up during forecast 2015-10. Now, if we look at this for reporting and analysis, talked about this here. Just give me a sec. If you have need for a separate reporting and analysis model, oh, there's another typo. Sorry about that. That model should feature a simplified version dimension that only contains official submitted version. How is that? Or why is that? Well, excuse me, that was the wrong. All of these iterations that I have here, right? This is really irrelevant for reporting and analysis. So what we have here is a very granular, detailed version dimension design for a contribution model, where people might want to look at iterations. What was the difference between iterations? Why do we have so many iterations? Can we improve this? Are we being too granular? Right? For reporting and analysis, that's not really what we'd want. We just would want the open versions. We'd really want only submitted versions in here. So, so for reporting and analysis, you would only use the versions that are relevant in the context of reporting and analysis. It simplifies security, maintenance, and greatly improves user friendliness. So your data belonging to the working forecast or plan and your what-if versions should not be shared with the reporting and analysis model, right? And this is really what the design would look like for a pure reporting and analysis version. So you see their current forecast and current plan, they're now leaves. They're not sea levels anymore. And as you can imagine, this is pretty easy to process too. We have customers where we have a separate reporting and analysis model. What we're really doing, we're processing the current forecast from the planning model, which is a sea level element, to the leaf current forecast, right? So it's really easy to TI process as well. It's the same principal structure, only that in the case of reporting and analysis, it's simplified. So with that, before I get to key takeaways, there's another process here that I quickly wanted to mention that might be useful for you. There's an actualization freeze process that we have documented as well. Is that that process you can use to actually move a forecasted, to freeze a forecast value that was rule derived. So what this process allows you to do in models where you might, where you want to freeze prior forecast values in that same version, what this process allows you to do is to export all data for a specific month to a file, have TM1 automatically move the current forecast month 1 month ahead. And then if you have a rule in that open version that sets prior periods to be non-rule derived, it can import the data from the file back into the cube, where at this point it won't be rule derived anymore. That being said here, the key takeaways, version management design matters a lot, and matters the more data you have. It's really your pivotal starting point to good, fast, and functional version management, scenario management. And as you saw here with the variance analysis, a proper version design will allow you to include many additional analysis features without much additional effort and without incurring performance penalties at all. See, all these variance rules, they're so generic. If you go to a customer, implement this methodology, you really have that block of code, and you literally copy it into each cube where you need it. You might make some minor changes, and you're done, right? So, in that context here, in most cases, you can really standardize your version management using a generic template like the one we've discussed here and presented in this session. Just use it as an example. Take a look at it. Provide us feedback. What do you think? One comment here. For very, very large models, it can at times be faster if you modify the version management process, that we ran in today's session, to actually do a data export to a file and then import it back in. The current version here just does a standard copy of the data in the context of the TI process. So we'll go with the simple approach when it comes to our example and template, and we may modify it if we find that the models really move a very, very large amount of data where we have to tune the TI processes a little bit. So with that, are there any more questions?
I don't show any questions at this time via the chat box, Andreas. You've explained it so well, everyone has it down pat. Again, if you have a question, please post it via the chat box for Andreas. And once again, we thank you for taking the time today to attend our session. And we look forward to seeing you on Thursday, where we have our final session of the series. And we also have coming up Q4 sessions, a set of series 6 sessions, and once again around the TM1 and planning analytics as well. So keep up with your education and feel free to join us.
Thank you very much, everyone, and have a great day.
Thank you, everyone.